System. I'm Merkle-Tan, and as a member of the Databricks Specialist Solutions Architect team, I work with healthcare and life sciences customers to tackle their pressing machine learning and AI challenges. Today, I will be sharing with you how I say goodbye to some cluster wait times and welcome faster library loads. If what you see here on the screen feels familiar, you'll likely have signed up for the right session. We have had customers reached out because of long cluster libraries installation times. For example, customers using R might have a set of 20 additional libraries and their dependencies that need to be pulled down from their package repository and installed onto their interactive clusters before they can get a crack on their task. The most frustrating aspect of many customers' experience is that they start to multitask when they are waiting for their clusters to spin up. And often they return to find that their cluster is actually terminated because of a period of inactivity while they're being distracted during multitasking, forcing them to start from the start. If this is familiar, maybe you are in the right place. Cluster libraries can take a while to install after the cluster is spun up and ready for use. And it takes roughly approximately 2 to 5 minutes for this to work. So the cluster takes about 2 to 5 minutes to spin up. And depending on your requirements, your project requirements, you may have a set of libraries or packages that could take anywhere from 15 to 30 or more minutes to pull down from the repositories and then install onto your interactive cluster. For example, these PyTorch libraries would take upwards of 30 minutes or so to install. And bear in mind, this process is repeated every time you spin up your cluster. However, we're here for a different reason, because there is another way. Imagine a reality where all of your, for example, 20 or so R packages would be pre-installed and loaded to the cluster. When the compute is ready, you can simply import these relevant libraries onto your notebooks and start working with whatever you need to do. So I'll demonstrate how this could work if you just give me a minute to swap the screen. Here we have a notebook, and I'm going to attach it to a cluster that has been spun up. Specifically, I'm going to show you too that the configuration of this cluster does not actually have any libraries installed. We'll go back to the demo here, and we'll check the library paths. We can see on the screen here too that there are some default library paths that's already installed, and one curious one that's associated with this demo. We can load up some libraries that are extra in addition to their default libraries on the cluster runtime. Here I'm using the R companion. And once it's loaded up, I can take a look at a specific module, for example, compare LM, and take a look at the reference of how to use it. So in just 11 seconds, this library is loaded up. We can take a look at the reference code for how to use this function, and we can test it out. We'll just load up some dummy data, write and define some linear models, and compare these models. Because this is not a data science demo, I'm really more interested in where the library that I've loaded is located. So here we ask the system file, and it's showing me that it's located at this mounted path that's associated with this demo. We will go into more details about how this come about, but I also wanted to highlight that there are cases where the default path, for example, the ggplot2, is pre-installed during cluster setup. And if you happen to use an extra package that will be requiring a different version of the ggplot2, you would have to specify this load path when you load it. In this case, I'm specifying this path of interest such that it will then associate it with their appropriate version, and then we can test it out to see how it works. Here I'm using the GG points to showcase that once it's loaded up in the right, with the right path, I can actually plot categorical line plots with vehicles of whether they're automatic or manual transmission based on their miles per gallons and the weight of the vehicles. Similarly, I can do this for the radar plots for the famous iris flower data set, where you can then generate the different species with respect to their petal and sepal dimensions. However, if you're going to use ggplot2 on its own, either of the versions should work. And here is a very quick example of plotting the diamonds data set, just for illustration purposes. A quick highlight here that the paths for searching the libraries are searched based on how they're appended to the search path. So in this case, the loaded libraries are appended at the end relative to the default paths here. So going back to the slides, I am going to summarize what we've just seen here. That without using cluster libraries, we were able to very quickly load up the extra packages of interest, and which means there's no additional cluster wait times beyond just waiting for it to spin up. So what is the secret sauce behind this? We know that we have pre-installed some of the libraries onto a path, and in this case we have loaded it onto a cloud storage, and we'll mount this with read-only access after it's been properly installed. This mounted path is appended to the default library search path for either R or Python. In the case of R, it will be the .lib path, or for Python, it will be the system.path. This snippet of code is where we'll specify in the file associated with the R profile or the IPython profile startup file paths. Crucially, we will create a symbolic link between our user-defined R profile files and the default profile file paths. This is important because these profile files are automatically sourced during the R startup or the IPython shell construction process, and they will be executed before any other code. Then we take advantage of the volumes in its script to package this symbolic link, and then we add this volumes in its script to the cluster advanced options, such that when you spin up your cluster, you would have the paths appended with all their libraries installed. So we're going to take a look at the realization of this approach in the next example. So I'll go into the Python example here. We are going to reattach my cluster just for a refresh. And I also want to show you that the configuration of this is such that I don't have any libraries listed for installation, but under the configuration and under advanced properties, I'm going to show you the path of volumes linked to my cluster. And we can test it out back in the demo here. Let's check the system paths. So we see that it's already associated with my cluster right here. And I can import, for example, the torch geometric module that was already pre-installed. Typically, when you do this, it takes up to more than 20 minutes or so to bring down the required files and install it onto your cluster or your notebook. But it will take about 20 seconds or so for this to show up. And it's there. It tells me that it's a version 2.53. And I can quickly also load up additional modules for the next set of examples. And I can do a quick test here. So it does work as expected. And I'm going to do a quick illustration of the scenario where your colleague or collaborator has just shared you some code that requires additional libraries, such as these PyTorch geometric modules. I'll just use the publicly available examples from PyTorch geometric collab examples, and I will run the subsequent code just for the sake of time. This is just to illustrate that if your colleagues have shared code with you where you have to download data and have to spin up a GPU cluster with all the required libraries, this is going to run when your GPU cluster spins up. So in this example, we are loading the data set from Cora, where it's a network data set where each node is characterized by a bag of words feature vectors. The node represents documents, and if there is a edge between the nodes, it's because there is a citation link between them. This goes through an example of a basic multi-layer perceptron network that doesn't do very well, but once you add in the connectivity indices as edges and train a graph neural networks, you will see that it starts to learn the categories of these documents, and you have the structure of the classification really readily available in a few minutes. So what we've just seen here is that essentially, instead of waiting for 30 or 40 minutes for your cluster to spin up and all the libraries that you need, we have been able to spin up the cluster and get to the work that we wanted to do. So what are you going to do with your extra time now? Apart from being faster to getting started with the task at hand, this approach has additional benefits. We're able to document the list of specific project files, the requirement files, and libraries associated, as well as the installation process. We can troubleshoot where installation issues arise rather than wait for the cluster libraries installation to fail and then have to troubleshoot that. Additionally, this approach is reusable and flexible for setting up other environment profiles where you have projects that use different libraries. It is also extendable to workflows and jobs. And additionally, you have shareable assets such as the volumes in its script, as well as the pre-installed library paths for other users and collaborators via permissions. So if there's only one thing you remember from this session today, is that if you pay it forward and pre-install all the libraries associated with your project, then they will be available every time your cluster spins up. And with that, I'd like to thank your attention and to acknowledge the contributions of my colleagues, as well as those who brought and surfaced customers' issues to our attention, and my colleagues who saw the value in proving out the solution to share with you today. Thank you.